Let's have a look at the following example. So we have a data set with 12 points, 16, 14, 15, and so on. And we want to get the mean of this data set. So mean we denote by x bar. So mean for a sample we denote by x bar. So to calculate x bar, what we do is we sum over the values xi, so where I equals 1 to n, and we divide by n, where n is our sample space. Alright, so 16 could be our x1, 14 our x2, x3, and so on. Okay, so we're just summing all those points and dividing it by n, and n here is 12. Alright, so we'll just go 16 plus 14 plus 15 plus 17, 17. So even though it's repeated, you got to write them out again. Plus 16 plus 18 plus 42 plus 17 plus 14 plus 13, all divided by your n, which is 12. And if you were to plug that in, you should get 18. Alright, looking at the same data set, we can also get the mode. So recall that mode is the most common value. So in the data set we have here, we've got 17 appearing 4 times. It's the most common value, so our mode we say is 17. We can then go on to calculate the median. And before we do that, we need to arrange our data in ascending order. So from smallest to largest, we've got them arranged there. We then need to find the position of median. So remember, median has to do with position. It's the middle point in your data set. So to calculate the position, what we do is we take n plus 1 and divide it by 2. In this case, our n is 12. So 12 plus 1 over 2, and you'll get 6.5. Alright, now that we've calculated the position of our median, we go back to our data set that we've arranged, and now we need to figure out where the 6.5 position would be. So that would be the first position, second, third, fourth, fifth, sixth, seventh, and eighth, and so on. So we calculated our median to be sitting at 6.5. So that would be right there in the middle. Now to get our median, the median lies between those two values, lies between 16 and 17. So we just find the average there, 16 plus 17 divided by 2, and you'd get 16.5. Let's see now what happens if we remove the number 13. So if we remove the number 13, we would only have now 11 values in our data set. So to get the position of the median now, again we use n plus 1 over 2. So this time we have 11 plus 1 because we've removed the value 13. And if you were to plug that in, 12 over 2 is just 6. Right, so looking at our data set here, where we have 11 points and 13 removed, the median would sit now in the 6th position. Alright, so you count through again and notice that 17 is our median in this case. So when you have an n that is an odd number, then your median is going to get to an actual value in your data set. Whereas where we had an even number for our sample size. So when we had 12 values, then we had to take the average of the two middle values. Let's look now at the comparison of mean and median. When would we rather want to use the mean, and when would we rather want to use the median? So the mean is great when we have data that is symmetric and where there are no outliers. Okay, so data being symmetric, it's got quite a even shape, and with no outliers. The outliers are your extreme values. So values that are too big or too small when compared to the rest of the values. So they're sitting way out away from the rest of your values. The median is great when our data is not symmetric. So there's maybe some skewness there. And when our data has outliers. So recall that median has to do with the position. It only has to do with the position. So it's not going to get affected by outliers. Whereas the mean relies on the actual values of the data points. So if you have an outlier, that's going to skew, or that's going to alter your mean or your average of your data set. So if we carry on with the same example now, and there's our values, we calculated mean, mode, and the median. Here's a dot plot of our data, and our median would lie there at 16.5, our mode would lie there at 17, and the mean there at 18. Notice with this data set that we've got an outlier. We've got 42 that's sitting way out on the right hand side. So for this data set, the better measure of central tendency would be the median, because there is an outlier, and you can see that the calculated mean is just to the right of the median. So it's almost like it's pulling towards, or the outlier rather is pulling it towards it. Okay, so that outlier is making the mean greater than the median. Let's have a look at this example on service satisfaction. So say you ask 9 people to rate the service at a local restaurant. A Likert scale is used to measure their responses. So they could respond with a 1, which indicates very good, 2, which would represent good, 3, average, 4, poor, or 5, very poor. So notice that our response is a qualitative variable, and it's of the ordinal measurement. So it's often that we use the Likert scale in this case. Right, so here we have the different responses that we've received from the 9 customers. So good, good, average, bad, good, very good, bad, average, very bad. All right, so if we tally that up, Very good, we see appears once, good 3 times, average twice, bad twice, and very bad once. So the most common response was good. So we'd say that the mode of this data is good. We can also calculate a weighted mean. So this would be used when not all the data points are equally important. So to calculate the weighted mean, we take x bar denoted with a subscript w, and we sum xi times wi over the sum of wi. So where your xi is the data point and wi is for the weight for the data point xi. Let's make use of this now in an example. So say you want to calculate your final Stat 113 mark. Right, so your marks, you get 53% for your DP and 49% for the exam. Alright, so these are weighted differently. So say DP counts for 35% of your final mark, and your exam counts for the remainder 65% of your final mark. Alright, so then you want to calculate a weighted mean. So what would you get as your final mark? So your final mark would equal x bar weighted, which would just be your mark for your DP, 53 times its weight, 35, plus your mark for the exam times its weight, 65, divided by the sum of the weights, 35 plus 65. And if you were to calculate that, your final mark would be 50.4%. So notice in the denominator, that is 100. So where your weights are a total. Okay. So let's have a look at examples. So we've got this group data, we've got class limits, first class being 15 to 20, 21 to 26, 27 to 32, and so on. We've got the frequencies, so there's 3 in that first class, 9 in the next, 15 in the next, and so on. And you can calculate the midpoints of the class limits. So for the first one, you'll just take 15 plus 20 divided by 2 gives us 17.5. The next one would be 21 plus 26 divided by 2 gives us 23.5. So say we want the mean for this now. So X bar for group data, we sum I equals 1 up to k, where k is the number of classes, midpoints times frequency divided by sample size n. Alright, so here we have 5 classes, so k equals 5. If you were to sum up your frequencies, n you would get 53. So to calculate X bar, we would take the first midpoint, 17.5, times its frequency 3, and then add 23.5 times frequency 9, and so on, until the last class where we have 41.5 times by 10, and divide by n, which is 53. If you were to plug that in, you would get 31.877. So we can also calculate the mean, median, and mode in Excel, which we'll go through a worked example in another video, but just as an overview of how to do it, you'll enter your data, you'll type in the command in Excel. So to get mean, we use equals average and then select your data array. To get median, we enter equals median, select your array, and to get mode, we just use equals mode with your array selected. We can also calculate the mean for group data in Excel. So recall that the formula for the mean for group data is given by X bar, and then we're summing the product of the midpoints times the frequency over the sample size n. So when we do this in Excel, we need to build it up. So the numerator, we use equals sum product, because we're summing a product at the top there, of array 1 and array 2. Where array 1 could be your frequencies and array 2 your midpoints. The order doesn't matter here, so you could put your midpoints first and then your frequencies. And then we need to divide this by the denominator. So the denominator, we have equals sum of array 1. And array 1, that's just your frequencies. So remember, when you sum up your frequencies, that just gives you your sample size n.